G'day guys, how's it going? So in this video, we're going to focus on operators. And basically the first two sets of operators that you will learn in Rust is the assignment operator and basically arithmetic operators. So let's get started. So the assignment operator is the first one. There's only one of them. And you've been pretty much doing this the whole way along. So when you declare a variable, let's say let add result, and we set this to 1 or something, this equal sign is basically the assignment operator because you're assigning a value from the right to a variable on the left, right? That's essentially what an assignment operator is. It's just assigning a value to a variable. Pretty straightforward, right? So that's all you need to know about that. Now, arithmetic operators, there's quite a few of them, right? And they're your basic math related ones like add, subtract, multiply, divide, and then there's this one called modulus, which is around remainders. So it looks a little something like this. So say I want to add two numbers together. Well, you just go 2, and then the little plus symbol, as you would expect, and then say 5, right? And that's a simple addition. So the plus separates the two numbers. Now you can continue to add more. You go plus 3 and so on and so forth, right? But overall, think of most things you can do in maths, and they probably apply in Rust. So that's an addition. Now if we go subtraction, and let's say I want to set this to 21 minus, in this case, a hyphen, 15, all right? So that's how you do a subtraction operation. Then we got multiply. So that's equal to, well, you might go 3x8 because a lot of people think an x looks like a multiply sign. But in most programming languages, it's the asterisk. So we'll say 3 times 8 like that. Cool. If I save that and then I print out the results of these. So let's go 2 plus 5 equals add results, like so. And then I'll just copy this 2 more times. And then we'll just change a few things up here. Sub result, mult, result, and 21 minus 15, and 3 multiplied by 8. Whoops. Now, if I save this and I run it, you're going to get what you expect with basic math problems. 2 plus 5 is equal to 7. 21 minus 15 is 6. And 3 times 8 is 24, right? Which are all correct. So they're the first 3 arithmetic operators. Now, the next one is a little bit trickier if you've never done programming before. But essentially, it's the division operator, obviously. So the reason why it's tricky is it behaves differently based on whether you're working with integers or you're working with floating point numbers. And I'll show you what I mean. So if I declare another, I must have hit caps lock. If I declare another variable, let's say an integer division result is equal to, now let's use 2 whole numbers, right? So 12 divided by 6, right? So we know that's going to be equal to 2. So if I print this out, so we'll just do that down here. I div result, and I'll just put 12 divided by 6. Now, if I run this, you expect a whole integer to say 2, right? And it does. Cool? So that's a simple example of an integer division. But if I do something like this, where I have 12, and I'll just rename the variable first. It says say 12 divided by 6, which is equally 2. If I now say 12 divided by 7, well, what's going to happen here? Well, let's find out, right? Let's actually execute this code and find out what this does. So 12 divided by 7 is equal to what this result is. So run that. And what you're going to get is 12 divided by 7 equals 1. Right? It doesn't equal a decimal number. Like you expect it to be something like 1.83 or something like that, right? But because we're doing an integer division, i.e. on both sides of that division sign, they're both integers, it will basically say, okay, what you want is an integer to be returned here. So what I'm going to do, or what Rust is going to do, is I'm going to round down to the nearest whole number. I'm not going to round up because that wouldn't be accurate because there isn't 2 7s and a 12. So I'm going to round down to the nearest whole number, which in this case happens to be 1. Okay. So just a little gotcha there. If you do this for the first time, you might expect to get a decimal number. You don't. All right. Now, if you do want decimals, well, you have to use floating point numbers, right? So we'll go let fp div result equals, let's go 10.4 divided by 5.2, right? So that's basically 2, right? Because if you times 5.2 by 2, you will get 10.4, right? So I've tried to make the result an integer number. But what happens when we do this? So 5.2. So if I run this, what you're going to get is it's going to spit out 2, right? But have you noticed up here that the thing has been marked as an F64? And that's because both sides of the equation here are F64s. Cool? Now, there's a couple of gotchas with division still, right? What if I wanted to, say, divide a floating point number by an integer, right? So if I do something like this, fp div to result equals, let's go 10.4 again. Well, let's just divide by 5 this time. Now, what's going to happen is when I save this, it's going to indicate there's an error, right? Now, if I also run it, you'll see it. The error could not compile arithmetic operators, and then it says based on a previous error. And basically, it says that you can't divide a float by an integer. Okay, so basically both sides of the equation, if you have a floating point number, needs to be float, right? But at the moment we have an integer. So can we get around that? Well, we can. We can use something called casting. But, I'll explain more what casting is in the future. But essentially, you can do something like, okay, I want the thing on the right-hand side of this equation to be an F64 as well. And when I do that, now the result is an F64. And then ultimately, I can print that out. All right, so now I can come down here. I can print out that result, which basically converts that 5 to a 5.0, just for context. Right, so now if I run it, you'll get no errors. And what you'll also see is it'll give you 2.08 because 10.4 divided by 5.0 would equal 2.08. So it gives you a decimal result as well, right? Because you're using two floating point numbers that don't exactly fit completely into each other. Cool. Now, on the flip side, you may have the opposite way and wonder, oh, can I go an integer divided by a float, right? So say I wanted to make this a 10, and then on this side, let's say 4.4, right? And I'll get rid of that cast there. Will this work? Well, the answer is no, it won't either, right? It actually still complains about the same thing. This time it says you can't divide an integer by a float, right? So basically, Rust tries to prevent you from doing anything where you're using one different type to divide by the other, okay? So it's like, nope, this has to be a float as well. So again, I can put it as a F64, and that problem should go away. and the whole result now will be an F64. Cool. So let's just quickly print that out just to see what it does. So we're going to go 10.0 divided by 4.4 and save and run. And now you're going to get a little bit more precision in your answer, because 10 divided by 4.4 is not an easy little match. It requires a lot of decimal places to get to that. But I'm assuming, and this isn't always true in most CPUs, but I'm assuming that if I was to multiply 4.4 times 2.272727, so on and so forth, that would eventually reach somewhere near 10. In fact, let's give that a go. I haven't actually tried this. So let's grab these two values. And we'll just go mult float equal 4.4. Now, I haven't tested this ahead of time, so it's going to be interesting. Print line. Oh, I should just copy the one above. So 4.4 multiplied by this large number. And save and run, and let's see what we get. And you can see it actually gives us 10. All right, so it was able to completely find a decimal that exactly matches 10. Sometimes what happens with some CPUs is that you may get a bit of a rounding issue where there might be like 10.000000001. It really comes down to the number of bytes that you use to estimate. I think with an F64, the likelihood of getting an accurate result is a lot higher than what it would be if you're using 32 bits, because you've got less precision in 32 bits, right? But yeah, sometimes you will see a situation where the numbers don't quite add up. But in this case, it did, right? So just be mindful of that going forward, that you may not always see the same result the other way. That's all I'm going to say. Lastly, there's one more arithmetic operator, which is the remainder, or what we call the modulus operator. And that looks a little something like this. So let's rem result equals, and let's go 10 percentage 3. So what this is going to do is it's going to get the remainder of 10 divided by 3, right? So 10 divided by 3 isn't like, it's not like there's a remainder left over, because 9 divided by 3 is 3, but then if you add 1, it'd have 1 remainder, right? Does that make sense? So in this case, rem resolve should return us 1. So let's just quickly test out that theory. So I'm just going to copy and paste that line again. And read this down. Whoops. And that. So 10 mod 3 should return 1. That's what I'm expecting. And it does. Yep. Because there's 1 left over, right? Now, just to show that it can work for floating point numbers as well, it will behave a little bit differently, but it can work. Results equals, let's go 10.2 modulus 3.0. And again, just like with the divide, you can't use a float and then an integer on 2 different sides. So I'm going to make that a floating point number by just typing 0.0. And now I'm just going to quickly see what that comes back with, right? So keep in mind, this is not, so this is 1.2 over the 3.0, right? So it should technically return 1.2 But you're going to see that issue that I just mentioned, that precision problem, right? If you think about it, 10.2 divided by 3, right, the remainder should be 1.2. But the floating point number is calculated as 1.19999. So it's very close to 1.2, but it's not exactly bang on, right? So that's just something to keep in mind sometimes. There are precision issues depending on your CPU. Yeah, essentially, it's just something to keep in mind as a programmer. You shouldn't always assume that everything you do with floating point numbers is going to be completely accurate. And there's different situations where they will be less accurate, especially if you're working with highly precision-based numbers and you're doing complex commutations or divisions or multiplications and things of that nature. But for the most part, usually they round out to be the same. And you can use like math.round, and there's a lot of, there's a lot of libraries that we'll use later that will basically deal with some of these issues when we use them. But for now, if you use basic mathematics like this, you might run into that situation from time to time. Cool. So that is the assignment and arithmetic operators in Rust. So I'm going to go now. Thank you for watching, and I'll see you all next time.